Hello everybody, this is a quick video about the PCA filter in Homer 2. First, it needs to be noted that the function actually expects y as data input. I actually had to alter this prior to using it. I think this is a remnant of Homer 2's previous variable changes. So previously y was actually a data matrix. Currently it's actually D, which is raw data, or DC, which is delta concentration or your concentration data. Depending on which you use, the PCA filter will act either on a three-dimensional matrix, which is your oxygenated, or excuse me, your hemoglobin species, if you use DC, or your wavelengths, which is if you use D. One of the first steps is it's actually going to take the data, transpose it, and multiply it by itself. So on the left, you actually see the original data in voltage. On the right, you actually see the new C matrix, or the C variable, which is actually a square matrix of the transpose of the data multiplied by itself. What this enables is actually singular value decomposition. I won't go into too much detail on this because I am not the expert and there are several videos on YouTube to explain it. But basically you have a data matrix A, which is equal to three separate matrices, one of which is already transposed. If I take the transpose of A and multiply it by itself, I then get this formula. It is noted that this U transpose times U in the middle actually becomes an identity matrix, and which is going to be used, but it also must be noted that in Homer 2 they alter the names of the variables. So first and foremost, A transpose A specifically will become your C. U will actually become V, S will become ST, and V will become foo. On here on the right, you'll notice that C is now D transpose times D. This will relate to this A transpose A right here. The new data, or your output, will now be computed. Basically, you take the original data and you subtract the original data times something of a variation of the identity matrix multiplied by EV. EV, and in that order, of course, because it's matrix multiplication. EV is a diagonal square matrix with a number of principal components on the diagonal. So let's say I select 2. There I will have 2 ones on the diagonal, and then the rest will be empty. This is designated as the NSV, which is the input variable to the principal component filter. To show you what these look like, the V matrix looks like this. When I multiply the transpose by the V, it looks like this. The ST looks simply like this. The foo looks very similar to the V, although they are slightly different values. Your output now is, here's your original data, and you'll notice here's your filtered data. So what you're going to have is a very small change between, if you notice specifically at the very end here, you'll have a very small change at the ends, and this is showing you a comparison. So the blue is the original data, the red is post-PCA, and this is all done for channel 1 in just a basic finger tapping experiment. Anyway, I hope this helps explain what this filter does. Of course, there's more videos on the actual raw statistics side of it, but I do hope it was helpful.